be talking about maximizing data for reverse 911. So this is a project we did for a city that we work with. And just to kind of set the situation, it was a local city government agency who had an existing GIS. They had an existing 911 reverse notification system that we needed to work with. Both had to work together. And the county was currently processing data there, but they only had a 65% match rate for mobile numbers, and this was unacceptable for the city. They wanted a much higher match rate for notifying their mobile users when there was an emergency. So, and fourthly, the city and county systems could not interface with each other anyway, so even if the city was happy with that 65% match rate, there's two systems didn't talk to each other. So they needed a solution and they needed our help. So some other complicating factors were that the county process was non-repeatable, it was very slow, and it didn't have very good results anyway. And there was no documentation of the county geocoding process, so they had no confidence in the data results. Even they were poor, but they didn't even have very good confidence in that 65%. And they got erratic updates, so they could never count on getting their data on time. And then there was jurisdictional battles between the city and the county, which just further complicated them getting along and getting anything done. So some major factors that we had to deal with in getting this project done was that there's two mobile companies, AT&T and Verizon, and they delivered their data differently. AT&T delivered their data to the city once a month, and it was a data dump of everything, while Verizon delivered weekly updates, and it was just an incremental change. So they didn't give you all the data every week. They only gave you, here's the 100 records that changed from last week. So, and there was an inability to get AT&T and Verizon to make changes to the data anomalies. So if the city found errors in the data, AT&T and Verizon didn't care. They weren't going to fix it. So, and then the city also had multiple sources of address information that they had to try to match to. So our plan was to document the address data sources from the city to determine a hierarchy of processing order so we could figure out which data are we going to try to match to first and which is the least accurate data, and we'll save that for the last if we can't match to anything else. We need to normalize the addresses from AT&T and Verizon so that we can match them with the city data. And we need to deliver a geocoded data set to the city so that they can have it in their mapping application. And finally, we need to deliver to them a list of the unmatched addresses so they know that these are the customers that you're not going to be able to call in the event of emergency because we don't know where they are. And then we also delivered a documentation of the entire process so they knew exactly what we did and how we got there. We decided to take a granular approach to the project. Instead of trying to process everything in one giant FME routine, we first wrote an FME routine to process just the AT&T data, next the Verizon data, then we combined the data sets into a single data source, and this is where we normalized it so that we would be able to match it with city and county data. And finally, we geocode the data so that we can put the points in the map. And we used a scripted batch file to automate the processing at the end so that once a quarter when we run this, we don't have to go through and update all the FME routines. So AT&T data was really straightforward. It's a CSV file. The only obstacle really in it was that the street information included the name and the street type all in a single field. And in order to match that to city and county data, we had to split those apart. So we had to use substring extractors, attribute trimmers, and testers to break that information out into separate fields so that we could match it with the city and county data. Verizon data was a little more challenging because they gave us just a text file. So we had to use substring extractors to break that out into the separate fields like APN and address, that type of information. There's also a field indicated if it was an update or insert or delete. And it was critically important that the Verizon data be processed sequentially because they delivered an update every week and it was just the incremental changes from the previous week. And we processed the data once a quarter. So at the end of each quarter, we'd have about 13 weeks worth of data from them. and we'd have to process that sequentially to make sure that the changes happened correctly. So, and I'm going to talk more about that. So we noticed after working with their data that we couldn't always count on if they said it was an insert. Sometimes the record already existed in the database, or sometimes they would say it was an update, but the data wasn't there yet. Or they'd say it was a delete, but it was already removed from the database, so we couldn't just count on what they said. So we did a tester to test to see, does this record already exist in the current Verizon data? If it does, it goes up, it passes the test. And then if they said it was U, C, I, or M, then we update it. And just the D for delete, we would delete those records. If it failed, it means it wasn't already in the database. So we know it's an insert, regardless of what they said to do with it. We know it's an insert. And if they said to delete it, then we don't have to do anything because it's not there anyway. So otherwise, our FME team kept bombing out at this point because records that we thought were there weren't, and vice versa. So finally, we're merging the data sets together. So it was a really big data normalization process. There were just differences in how they did things, like spelling out First Street versus 1ST, or AV, AVE, or AVE period for avenue. Those types of things are a real heartache when you're trying to match data. So the first part of it was just fixing things like that, including we have a series of transformers we call the MC hammer, so that we can get rid of the MC spaces in the data, because those really cause a problem. So, and then there was things that were errors, like Green Oak Place should be Green Oak Drive. So those types of things we had to fix before we could match it to the city and county data. So in addition to misspellings that Verizon and AT&T refused to fix, they would acknowledge that they were spelled wrong, but they're unwilling to do anything about it. So here's just a little example of an attribute filter used to filter out the numbered streets. Then they go into a value mapper, so First Street becomes first spelled out, et cetera. And then here's the MC hammer, where we search for MC space at the beginning of a street name, and if it exists, then we replace it with MC with no space, so that we can match it to the city and county data. So, the thing we love about FME is that you can write an FME routine, you can put in the known exceptions, and it only needs to be done once. So we knew in advance we're going to be processing this data once a quarter, and we don't want to have to think about and remember all these exceptions every time. So we can document it in the FME routine, and it's going to be taken care of each time. And it was very quick and easy to incorporate new exceptions as they were found. So if next quarter we run it and there's a couple new exceptions that fall out, we can add them into our FME routine, then we don't have to think about them again. So the third thing is that the original source data is unaltered, so we have a clear audit trail of exactly what happened. So the fourth and final step is geocoding. So we finally got to the point where we were trying to get from the beginning of the project. And there was a hierarchy of data. So we first tried to match against the county assessor data. If we couldn't find a match, then we tried to match against the city situs address data. Next, the county assessor mobile home data, the city situs mobile home data, and finally the street centerline data from the city. This is the last of the data provided to us by the city and the county. If we couldn't find a match, then we had to determine, is this a valid address or not? If we determined that it was a valid address by talking to the city or looking at USPS.com, then we would figure out what the latitude longitude is for this point, and we put it in a lookup table. And that way we don't have to think about that point again. If it's an invalid address, then we put it in a known invalid address table. And our FME routines look at these so that we can match the data and we don't have to think about them again. So I kind of talked about this part with matching data to the lat long. If we have exceptions that fall out from our FME routines after we run all 4 of them, then we update the lat long lookup table or the invalid address table, or we add additional exceptions in. Then we would just rerun routines 3 and 4. And hopefully, fingers crossed, no exceptions fall out the next time. So here's some examples of unmatched like 201 for an exchange, 0 Air Force Base, 1 VoIP caller, or T-Mobile at home service. These are the addresses provided to us by Verizon and AT&T. So I don't know why we couldn't match them, but we couldn't. So, and finally, the great part for us is that we wrote a batch routine that we run to run the FME routines. We have published parameters inside our FME routines, and we call the FME routines and send the published parameters to them. So that way, we don't have to change the FME routines every quarter when we run it, because we've got the 1 AT&T source file plus about 13 Verizon files. So this makes it much simpler, plus we have documentation of exactly what we did. So after we put in the input names for the source files, we just run the batch routine. And we come out with a beautiful map. So here's the points on the map. You can see the green stars are where we match to county assessor data. The yellow stars, there's just a few of them, are matched to the city site address points. The red stars are matched to roads. And then there's one pink one on here. This is a lat-long lookup. So that way, when the city is looking at their GIS, they can see very quickly how the points were matched, and just really quick visual scan to see how they were matched. Okay, so now to the whole point of what they wanted to do. If they have an emergency, whether it's a spill or they need to evacuate an area, they need people to shelter in place, and they need to notify them by the reverse 911 system, they can buffer a parcel or a bunch of parcels or streets, however much they need to. They can pull up a detail report that shows them all the customers with their telephone numbers and addresses that are in that area. And they can also click on the report to notify those customers of the emergency. They put in an event name and submit it. Gets posted to an FTP site, and then from there, since they were using a telephone emergency notification system, they would send that off to the company who did the calling for them with the recording. The exciting thing is, after listening to the presentations yesterday, it would be perfect for this city to use something like Twilio and use an FME web service that would monitor, use FME server to monitor that FTP site, and then they could have those notifications go out automatically, maybe by text message or automatically calling, instead of having to take the next step of having the emergency notification system actually call everybody. So that would be an exciting next step for this client. And results, FME saved the day. We had 99.6% of all records that we received were matched. 100% of all the records that had valid addresses were matched. So instead of the 65% that the county was getting, we were able to match everybody that had a valid address. It was fast. The initial project took some time, but after that initial project, we spend about half an hour every quarter. That includes copying the data over, running the FME routines, and posting it back to their GIS. It's very quick. And we have documented, traceable results of the work we performed. So if someone comes in and replaces me or replaces our people we work with at the city, we have clear documentation of exactly what we're doing with the data. And that is it. Does anyone have questions? Yes?
Are there any QC feedback mechanisms for the geocoding if the addresses don't match? Like, I work for an organization that collects all the addresses in DC from each jurisdiction and puts it into a single point database.
Mm-hmm.
But from each jurisdiction, we have QC mechanisms. So they have, say, an invalid street type. They get a report back saying it's invalid. Then they deliver on a weekly refresh. But hopefully during that next weekly refresh, that data is corrected.
So we would deliver to them a list of the addresses that we had in the lat-long lookup table. So those are all the addresses that we couldn't match to their existing data. In addition, we would deliver to them a spreadsheet. It's about 100 records that had invalid addresses for them to look at. So if the city wanted to go in and correct their data or do some further research on that, they could.
There is some work that we would actually, since we were working with the city and near the county and the assessor, on those instances, when we found, hey, you guys have a problem here, they would actually go in and fix the city
Yeah.
It was Verizon and AT&T that was
Yeah.
an absolute hopeless cause. If there was something wrong in their data, it stayed wrong, and we were able to, with FME, just accommodate their error and pass it through correctly.
Yeah.
But we did do a lot of work with the city and the county to fix any data issues that they had in their system. They were very happy to do that and very willing to do
Yeah,
that.
yeah. The city and county wanted clean data. It was just Verizon and AT&T who didn't care.
Yeah.
Yes.
I'm from Australia, Victoria. After 2009, the Black Saturday fires, all the telcos are now authorised to receive live cell phone locations for disaster plans. Have you even thought about looking at the systems they're using? I know they're using FME. Thank you. I know they're using FME, like Telstra and Optus.
We haven't looked at using anything like that for
so
this.
that's a live feed. So if your cell phone is in the path of a disaster, you automatically get a text message.
Yeah, we have not done that, but that is really exciting.
This particular city was more concerned about, okay, we have our residents that we need to notify. They had a mandate that they needed to be able to do that. So what they were doing was, if you have a residence that is within an area of an impact of whatever it's going to be,
Yeah.
then we had an obligation to notify you versus trying to get live feeds from all of the different cell providers.
Yeah. Well, this is countrywide.
Right.
It's not just Victoria, so the whole country had to do it. This is working.
No. Oh, yes, right here.
I'm the product manager for Geocoding at Esri. Can I give you my card?
Sure.
How many records did you do total?
There was about 40,000, I think.
Okay. Well, we'll talk offline.
Okay.
Okay.
I'll put some things up.
I'm still working on the basics here. So the real goal here is to associate the location of an owner of a cell phone with an address.
Yes. So all these stars are owners of cell phones. So AT&T and Verizon provided us with the phone number and the address.
Okay, even if they're somewhere else, it doesn't matter. They're still going to get that notification because they own property
Yes.
associated with that location.
Exactly.
Okay.
The issue we're running into is everyone's abandoning their landlines, and they're just going with either, a voice over IP or they're going with cell phones. And so the city was like, good grief, we have so many of our people that we can't notify because they're abandoning the landlines. We need to be able to do that based on cell phones because that's becoming the common way of doing it. So that was the impetus behind the whole project was how can we more effectively do that and get in the addresses and with all the issues associated with the addresses with AT&T and Verizon not fixing them, with the county having just a dismal.
So the addresses that you're working with are when I sign up for my cell phone, whatever I write down.
Yes.
So the data we got from the cell company.
Right. And it's
Yes.
as messy as it might be.
Yes.
So that was, the first part of the project was a relatively significant data cleaning process, but it went pretty fast. We probably spent, I think, a week on the first run through, just kind of getting all the data issues addressed.
I think we have time just for one more question.
Back there.
On your updates from Verizon and AT&T,
if somebody changes their cell phone number, because that's very easy to do now, you can just go online and change it if you want. Is that reflected in your updates
Yeah,
from
so
them?
if someone changed the key was the cell phone number in their data. So if someone changed their cell phone number, it would have showed up as a deletion and then an insert. So, and then they would have been geocoded.
Okay.
Thank you very much.